I'm talking to myself in the back of my car, but it's for science. To science. Well, so as you can tell, there is nothing but professionalism here on my channel. And all of my millions of subscribers know that already. A special shout out today to one subscriber in particular, Dr. Malavanti, because I have a hunch she might be the only one watching this. Shout out to HEB Sparkling Water for sponsoring this video. They haven't yet, but if they'd like to, call me. So today I would like to talk about peripheral vision and specifically how it applies to driving. I think peripheral vision is kind of something that people generally refer to. Everyone kind of has an idea of what it is. But to get a specific definition, in a paper by Wolfe, Dobres, Rosenholtz, and Reimer, peripheral vision is defined as the entirety of the visual field that is beyond the fovea. So that's a lot. Your fovea is really just like a tiny portion of your retina, but it is represented by a huge part of your visual cortex because it is so important. But basically anything that's non-foveal vision is considered peripheral vision. Another fun game I like to play on my channel is how many last names can I mispronounce? It's a really fun game that I love and my subscribers love, so I'll probably be doing that very frequently throughout this video. Okay, so what I'm here to tell you about peripheral vision that you might not already know is that it's really, really bad. The visual acuity that you have in your peripheral vision is very poor, much poorer than we would expect or that we would hope for because we feel like we have a seamless, clear view of the world. So in your eye, you have rod cells and cone cells, and just briefly, cone cells are what give you your acute, sharp color vision, and they're really, really concentrated around your fovea, which makes sense because that's where more of your clear vision is. But on the outer part of your eye, the more you move out, the more rods you're going to find. One of the qualities of these cone cells that are in the outside of your eye is that they have a really high convergence rate with the retinal ganglion cells that they extend to, that they connect to, that they communicate with. And so what this means is that the information from several rods is converging just to one retinal ganglion cell. And so this is really efficient and really effective for what we need this peripheral vision for, but it does mean that it's a less specific, less acute form of vision, if that makes sense. Are we on the same page? I think so. So circuits with this high convergence have a quality called spatial summation, and this means that the firing rate of the retinal ganglion cells increases as the number of photoreceptors that are activated by light increases. And if that sounds familiar to you, it's because it is straight from your slide that you made. So citation to Dr. Malavanti. That one's for you, girl. As I was saying, this spatial summation means that there is a less specialized input to these retinal ganglion cells, and that just kind of contributes to the less acute, a little blurrier vision that our peripheral vision provides. So another note on kind of visual perception before we move on is that receptive fields vary in size. So cells near the fovea are going to have a much smaller receptive field, and cells kind of on the periphery, those rod cells, the peripheral cells, have a much larger receptive field, and so they're getting more information, and so it can get a little muddled, and that's okay. We need our peripheral vision for so many things, and it's so cool and so important, but let's talk about why it's not ideal for a driving situation, shall we? So there's a really cool brain games video that kind of illustrates like how poor your peripheral vision is when you're relying on it as your only form of visual input. I will link it down below in the description box, and I highly recommend you watching it because it's very interesting. So what does all of this have to do with us? What does it have to do with driving? Well, I am so glad you asked. So with modern technology, there is, I feel like, a big push toward apps and features in the car that require you to look away from the road, but not so far that you feel like you're doing anything dangerous. For example, GPS systems that are either on a screen in your car or just mount up on your dashboard feel like a really good solution because it's giving you information you need to get where you need to go, but it's close enough to the visual information that you need that you feel like you're not really missing out on anything. But because of what I've talked about with how non-specific peripheral vision is and how poor it actually can be, it's just not a good idea to rely on that for your only source of visual input when you're doing something as important and as crucial as driving. So kind of to reflect this idea, in the Wolfe, Dobres, Rosenholtz, and Reimer paper, they talked about the useful field of view, and it was a test kind of to see what could actually be attended to in a scene. And they concluded that this information is informative, but it's not exhaustive for visual input while driving. But this paper did really emphasize how useful peripheral vision can be. But like I said, it cannot be the only form of visual input. It's not exhaustive for a successful driving experience. So for example, one of the benefits is that this study found is that you can get situational awareness. You can kind of get the gist of a scene without that much specific visual attention. So you don't actually have to be visually focused, honed in on one specific thing to kind of get the gist and get an idea of what's going on. But as we know, you just get so much more visual input than you even can attend to at one point, and so the gist of a scene is not enough to really make you a good driver. So don't try it at home. Don't try it at home. So basically, what this paper was saying is that when you are looking at something like a cell phone, like your screen, basically anything that's not the road in front of you, you're attempting to use this situational awareness by peripheral vision only without using foveal cues. And considering how important foveal vision is to like actually seeing what's going on, clearly that is not adequate for good driving. So in a paper by Ball and Owsley, they used a term called the useful field. And so that's the part of your vision, mostly foveal, somewhat peripheral, that you use to identify what's going on in a scene. So for example, when you're driving, if you're witnessing an intersection, watching people go in and out of it, it's kind of the circle of your vision that is successfully telling you what's going on. And this paper found that this field gets smaller with age, and even without other visual pathology. So that's not older adults who have a bunch of really bad eyesight problems, it's just any healthy older adult. So in another study by Andersen, Nye, Bian, and Kang, nailed it, they gave participants a virtual driving task in which they had to keep a specific distance from the car in front of them that was changing speeds, and at the same time they had to make decisions about a light that was changing colors kind of above the car. Not that important, but basically it showed that the increased workload caused a lot more errors in whatever task they were given. Also, maybe even more applicable to what I'm talking about, when the light switching task that I mentioned, whenever the light was situated more peripherally, people made a lot more errors, which just kind of reinforces that even when you're trying to pay attention to a task, things in your peripheral vision just aren't as accurate. So in another paper I found by Lee, VanRullen, Koch, and Perona, possibly, so they demonstrated a couple of interesting things that are a little contradictory, so bear with me. Target objects in a natural scene could pretty much be done without direct spatial attention, but under the same conditions, similar tasks involving synthetic stimuli, so like in this case they were using letters, so like L's and T's, and the participants had to discriminate between the two of them, they really couldn't do this without specific spatial attention. And so like for some stimuli when you're driving, you might be able to like get away with not really focusing on it, relying on your peripheral vision, but for a lot of stimuli, especially ones that are synthetic and novel, which if you didn't know is a lot of things while you're driving, you can't rely on non-intentional vision for that. You really have to be focused on what you're doing using your foveal vision. So I know a lot of this has gotten a little cognitive, but you know, I'm hoping that I'm tying it all back to the sensational and perceptual experiences of peripheral vision. I feel like the last paper that I read really ties that together really well. It's by Lee and Triggs. Also, I will have the actual citations for all of these studies listed in the description box so that you can reference them if you are intrigued, or just to make sure I'm not making things up. So this study was generally about detection rate of certain visual signals, and so it was another one where people were asked to detect certain stimuli in different levels of complex scenes. And so they found that whenever the simulated driving task was more difficult or the visual scene was more complicated, the detection rate of visual signals just went way down. Also, with the visual detection task, decrements were observed at all peripheral angles. So not only was just the detection task difficult for people in a complex visual scene or driving environment, the peripheral vision especially suffered. So obviously this has been a lot of information, really condensed really quickly. And what are we going to do about it? Let's chat, shall we? So driving distractions are always going to be present. There's always going to be something that you have to glance at or that you have to take your eyes off the road for a second for, and that's okay. Our eyes are equipped to handle it. But like I said earlier, a lot of the technology that's geared toward making driving easier and more comfortable is really taking our eyes off of the road. And considering all the evidence I've given, that is extremely problematic. So one kind of piece of technology that I might suggest that would be really cool, I am not that tech savvy, believe it or not, but how cool would it be if there was some sort of eye tracker either on your dashboard or near your steering wheel to kind of monitor where your eyes are. Hopefully for the most part, you know, when you're driving, you're facing forward, your eyes are about level with the street. But I feel like there's a way that we could monitor if a driver were to look backwards, to look off, to look down for an extended period of time, and just to alert them. I know that there's systems that if you're swerving too much, your steering wheel will vibrate a little bit. So something like that where it's not going to take you away from the driving task. It's not going to be a big commotion, but it's just going to kind of give you a little reminder hey, your eyes haven't been on the road in the past 3 seconds. Let's get it together. You know, I think just awareness of stuff like this is so important. I didn't realize how unfortunate my peripheral vision was until I started looking into this topic, and I think it's so necessary for people to know so that we don't rely on something that isn't really delivering what we think it is. So that's really all I had to say. I think there's so much cool research on this topic, on peripheral vision, spatial attention, and driving. So if you have any questions for me, be sure to leave them down below. Subscribe to my channel. Obviously, I have so many exciting videos out right now. So anyway, I hope you've enjoyed this video from my back seat. I hope you've learned a thing or two. I really appreciate you watching and your attention, and I will see you in class.